Hi everyone, welcome back to my YouTube channel, that is Tech Stack Learning channel. So today we are going to dive into the LangChain Document Loaders. So the essential foundation for building a retrieval augmented generation pipeline. So in the previous sessions, I have covered about what is LangChain, what is memory, right? And what are the conversational chains. If you haven't watched my sessions, please go ahead and watch the same. So before we get started, if you haven't subscribed to my channel, please go ahead and subscribe and give it a thumbs up. And if you have any specific topic you want me to cover, please put it in the comment box. So what are these document loaders in LangChain, right? Document loaders are responsible for loading data from external sources, right? Like PDFs, Word, files, or web pages, or from APIs, or from the database, or from the cloud storage, right? Converting it into a standardized document format that LangChain can work with, right? Basically, they act as a data ingestion layer for your AI or LLMs, right? This means that your model can read, summarize, or answer questions about your data without you manually pre-processing it, right? So that is where what are these document loaders are helpful, right? They're perfect for a wide range of use cases, um, like analyzing the research papers or generating insights from CSVs or pulling content from website or accessing cloud storage, which can be efficiently connect to your AI to almost any source of truth, right? Which gives the LLM the context it needs to provide a meaningful outputs. So you understood what is document loader. So what is the document in LangChain, right? Every loader in LangChain, it could be any loader, any type of loaders, right? Which we'll see in the upcoming sessions, the later on, what are the types of loaders we have. But in every loader in the LangChain, right, outputs actually one or more document objects, right? It actually outputs one or more document objects, okay, which standardize the data for LLM processing. So each document, right, has a page content, basically containing the actual extracted text, a metadata dictionary storing context like the source file, then URL, the page number, the author, or timestamp, right? This structures allows the content to be seamlessly integrated with text splitters, embeddings, vector stores, or the retrievers, so which ensures LLM has both the information and its context for accurate reasoning and mm, retrieval, right? So why document loaders are important, right? Document loaders are very crucial because LLMs cannot directly interrupt raw files, HTML or other unstructured data. They extract readable text, clean output uh, noise like scripts or formatting, preserve context through metadata. Then it can enable for the large scale ingestions, making the RAG more possible, right? So without loaders, what happens is yeah, the LLM may hallucinate, right? Which because of lack of grounding in real data. So that's the reason this document loader is the first step in any of this RAG applications, right? Where you see that the document is there, which has to be followed this particular sequence from text splitting to embedding to the vector store and then retrieve, which can be used by the agents or the LLM, right? That's why it is very crucial to have this loader first for any types of sources. So let's see a basic usage pattern or a high level flow across all the loaders which is available in the LangChain, right? So all document loaders in LangChain follow a common high level pattern, right? First, you choose a loader, right? Based on your requirement. Is it PDF loader? Is it a web loader? Or is it a CSV loader? Okay, for your data source. The next you will have to load the documents, right? That is the standard process, and finally pass them to the downstream systems, like it could be like for example, if you see the loader, this is, assume it's a PDF loader, the source, and you get the documents loader.load, right? And then it loads the document, and which can be passed back to the these documents can then be seamlessly fed into other downstream systems like text splitters and other vector databases or the retrievers, right? This is the pattern which always all the loaders follow. So here in the loaders, right, there are basically two code methods. Okay, one is dot load and another one is lazy load. Right, the dot load method performs eager loading, fetching all the documents at once. Right, basically it is called as a blocking until complete. Right, it is ideal for small data sets, for local files or for quick demos, right? But it can consume high memory for large data, and it also can have a slow for the large site, right? That's where this dot load will be applicable for, whereas the lazy load is majorly for the streaming, right? Uses the generator based streaming approach, loading the documents one at a time, which is a memory efficient, right? And non-blocking, it is streaming, right? So making it is very perfect for the large websites, massive PDFs, and also for the APIs or the streaming pipelines, right? So essentially, if you see, the load is simple but less scalable, but while lazy load enables safe, scalable ingestion without crashing your system, right? So making it the preferable choice for large data sets, right? If you see the comparison, memory usage is high for load, whereas it is low for lazy load. Speed is good for lazy load. Ease of use is this, but it on large scale applications better to go with the lazy load. And for large data set also, you will have to prefer the lazy load. Okay. So now let's see what are the types of document loaders are available in the LangChain, right? So it is a file-based, first one is file-based loaders, which handles the local files like PDFs, Word documents, CSVs, JSONs, or anything, right? Which is making them ideal for internal document or reports or research papers and the contracts, right? And then we have the website loaders, which scrap the static or the JavaScript rendered pages, crawl multiple pages, or ingest via the site maps, right? Suitable for the documentation sites, blogs, and the product portals, for the knowledge portals, right? Then we have the API based loaders, like pull data from the REST APIs, SaaS platforms, or the search APIs, which is very perfect for live or the frequently updated content, right? Then we have database loaders, which is basically to ingest the structured data from SQL or non-SQL or data warehouses, supporting business intelligence for CRMs or for the analysis purpose, right? And then we have the cloud storage loaders, which is basically used to access the cloud services like S3 or the Blob or Google Cloud Storage used in the enterprise pipeline, right? And then finally we have the special or the advanced loaders managed like emails, the notions, or the like GitHub repos or the Google Drive, which is majorly helpful for this knowledge assistant, developer co-pilots, or enterprise search, right? So in a RAG pipeline, the data flows from the source through the document loader into the text splitters, and then to the embedding, to the vector store, and then the RAG pipeline, right? So this is how the types of overall document loaders we have in the LangChain. So if you overall, if you see, right, this document loaders also has some kind of limitations in terms of like they can only extract text without they only extract the text without understanding meaning, right? Website loaders can be blocked by robot text, right? Then large files needs lazy loading, and JavaScript heavy sites need browser based loadings, right? And the best practices what you have to always consider is inspecting the documents before embedding, right? Using metadata for filtering, preferring lazy load for large sources, then choose loaders based on the content type. Don't do that like blind. You have to just ensure whatever you're taking, it is based on what your data source is, right? And combine loaders with text splitters. Okay, so in summary, if you have to say, right, document loaders ingest external data and output standardized document format using load or lazy load based on the requirement or what the data set you have. Okay, so that's the end of this session about the overview of the document loaders. In the upcoming sessions, I'll be deep diving with the live coding examples for each of the loaders, and you can see how to use it with an example. So stay tuned for upcoming sessions, and if you like my session, please go ahead and subscribe to my channel, give it a thumbs up, and if you have any specific topics, put it in the comment box. Thank you.